Shivashis is a student of computer science at NIT Trichy, India, and about to graduate later this year. During the day, he worked at Grofers in the data engineering team. He spent his leisure time dabbling with geospatial data, with Python, plants, and looking at old maps and photographs. With that, I'm handing this session over to our esteemed speaker.
Thank you. Hey everyone. So I'm Shivashis, and today we're talking about web map servers. So before I start our screen, share my screen, I would tell you how the session is planned. So for the first half an hour, we would be for the first half an hour would be talking some stuff, as in what setting the stage for what we are going to code next. So let me share my screen, and I hope everybody have fun. So my talk is Demystifying Web Map Servers, the invisible side of geographic information systems. So parts of it will be talking over the next set of slides. So let's first begin with a question. What is common among the products listed below? So the first is ArcGIS, and then Uber and Google Maps. Clearly, they're maps, right? But this is not a physical session where we can talk about physical paper maps, right? So we are going to be talking about digital maps and how they reshaped our world, right? So from early 2000s, there has been a drastic change in how we visualize and consume geospatial information. By geospatial information, I mean everything that involves a coordinate, right? So this is a sample image of a map. How, just picture how difficult it would be to see. So this is an example of carbon monoxide concentration in our atmosphere, right? So imagine how hard it would be to put everything in papers, as in this coordinate has this amount of carbon monoxide, but in maps it's so easy, right? So what is geographic information system? So any computer systems where we can use it to visualize or edit or draw information from geospatial data, or anything that involves location intelligence, right? So this is geographical information system. And yeah, we'll next talk about maps and how are they generated, how are digital maps generated, right? So yeah, okay, so okay, you agree that I'm going to be talking about maps, but when you ask what is the need to separate maps and map servers, as in why can't Google Map give us a single digital map to download, and we can use it later on, right? It's a huge task. Think about it. There are a lot of information in Google Maps, and there are roads, there are cities and countries, a lot of information. It would be terabytes of data, and you don't have any space, or generally you don't have any space to store them. That's why we do a client server model in this case, right? So we separate map servers and map data from the client which you use in your browser, and that's how we generally deal with digital maps, right? So this will be the connection. So there'll be a web map server, and then with an HTTP connection, you have a map client. So, okay, let's again go through the outline of the first 30 minutes, which we will be discussing about. So first, we'll be talking about basic geography and terminologies. Then we are going to be talking about how to create maps from this geographic data, right? And then we are going to be talking about, let's say you have some location information. For example, you have some location data, or let's say you have a data set on how many people turn up to vote in your constituency, right? How do you plot it in a map, right? And in towards the end, we talk about how to create a custom web map server. By web map server, I assume let's we all assume that we don't know anything about maps. Then a web map server would be something that provides the map which you get on your browser, right? So towards the end, we'll be talking about how do we create these custom web map servers. And this talk would not be about commercial usage, or the demo which I would be giving, they may not be fit for building a sample of Google Maps, right? But yeah, we'll be looking at all the concepts involved. Okay, let's start with our talk then. So let's go through a primer of maps and geospatial data in general, right? So the goal of this talk is not to get you very proficient in geospatial mapping, right? People work for years and years, and even I'm only a beginner. So let's just set a goal that everybody is a little more enthusiastic about maps in general, right? So okay, let's start with our content then. So first of all is projection. So these are some list of the topics I'll be talking about: projection, coordinate reference system, layers, types of views, and yeah, they would start to make better sense when we go through each one of them. Before everything, this is a sample web map server access URL, right? Let's go through this and see what we get. Okay, so I made some request to some server. There, it's totally a black box for us now. Now what I get is a beautiful view of a map with some data built in. Now look at the types of parameters here, because they will be very important when we talk about them later. For example, the service is web map service, and the version is the web map server's version, and we are making a get map request, and there is a bounding box, right? Like this can intuitively mean a coordinate system, right? There is 0, -90, this is latitude 1, this is latitude 2, this is longitude 2, right? And there are other parameters as well, and we would go through what each of these parameters mean in a while, right? And there are layers, right? There is blue marble and cities, and there are some styles. Let's now go back to the map we generated and tweak some parameters and see what happens, right? For example, if I go and erase the city, so I said there are two layers called blue marbles and cities. Let me remove cities and see what we get, right? So this is a plain view of a map, so you kind of get an idea of how I'm interacting with the web map server, right? This is the web map server, it's hosted in here, right? And once I change some parameters, it's going to give me a different map. So think about it. When you go to Google Maps and you try to zoom in and zoom out and try to load different satellite layers or map layers in dark, what you essentially are doing is you are passing some parameters to the map server and getting a map, right? Okay, that's what I wanted to show. Right. So first of all, we'll talk about coordinate reference system. Right. So what is a coordinate reference system? In the bare bone, they are just some coordinates, right? For example, you often use your coordinates as in some latitude and longitude to represent your location data, right? So the latitude and longitude, even if in our general like day-to-day life we use the same 0 to 180 and -90 to 90, it's not always the case. Okay, and there are different types of map projections, and corresponding to each map projection there will be coordinate reference system, right? So okay, before we'll come back to this, let's now look at a few diagrams to understand projections better. So let's say we have a globe, and look at picture A, and we have a globe, right? So unless we use a 3D globe, because in most of our day-to-day lives we are using digital screens, so we have to have 2D maps for them, right? Even you'd say after we started with 3D in digital screens, we are moving to a 3D world, but it has been like primarily the case that we view maps generally in 2D, right? So we have to first project the maps into 2D sheet, right? So how do you project it? For example, check out this image of a globe, and there is a cylindrical sheet of paper surrounding the globe. Now you place a light inside the center of the globe, the sphere, and then you cast a ray, the traditional raycaster technique. And then what you do is you plot, uh, as in, let's say this, I'm pointing to a location here in A, and you point it to where the ray falls in the rectangle sheet of paper. Yeah, so it falls in here, right? In here. Okay, so that's how mapping is done now. And there are different types of projections you can make. For example, you can use a cylindrical sheet of paper, or you can use a cone, or you can use a flat sheet of circular paper at the top, right? And think about it. Now when you put a light in here, the light which is going upwards, right, towards the north pole, it's going off forever, and you can never map the poles properly, right? So this is an example of distortion. Check this out. The image which we generate here, right, the grids which we find grow consistently wider when we go to the pole. I mean, you can see how it happens, right? It is just a sine theta of this component. And as in, yeah, so basically when you throw a light towards the top, it goes all the way to, okay, I cannot map it in my screen. So yeah, you get the idea how distortions occur. For example, in here as well, even if you throw some lights towards the top or left, there always going to be some sort of distortion, as in there might be a distortion in area or direction or the angle which the light is falling towards the sheet of paper, or the distance, right? So if you map these stuff in a digital format or even a 2D sheet of paper, you have to make sure while doing your calculation that um, what are the distortions we made when we created this map. Look at the next example. So the next example has some different types of projections of the USA, and how do they matter when we try to calculate distance, area, etc. Take the first projection, the Mercator projection, and in here, if you try to map this like this line segment or the boundary of the top three states, this is certainly and visibly different than this one and this one and this one. So unless we have a reference to what sort of distortion we choose to make, for example, in the form of PPSG 2955, and in here the standard form is WSG or WGS 84, and these are some projections, and we have to keep track of the projections where we build the map in order to do calculations on top of them. Okay, so let's jump back to the definitions and check what we learned. So map projections try to portray the surface of the earth or a portion of earth on a flat piece of paper or computer screen, right? So this is how we use projections to create the maps. And a coordinate reference system then defines, with the help of coordinates, how the two-dimensional projected map in your GIS is related to real places on earth. So unless we have the coordinate reference system names, we won't be able to do perfect calculations. Our calculations would be very erroneous. So, okay, they are coordinate reference systems and projections. Now, let's talk about layers now. So you must have browsed some form of maps, as in Google Maps or OpenStreetMaps. In there, in the right hand side, you might see something like satellite layer or paper map layer, or an old map layer from the 1500s, right? So you see why I'm using the term layers here, because you cannot possibly put everything you know in a sheet of map and give it to the user, right? You have cities, places, rivers, lakes, and there are population density data, there is literacy rate data, and all of this you cannot put in one map. So that's why we define layers. So when a user requires some layer, as in I want the population density data, so I make a request to the web map server saying, hey, I want the just the population density data as the layer, and if I want some more data, I just say, okay, give me population density data and the city data. Remember the URL we visited when we tried to build or go through how web map servers work? See, there are two layers here, blue marble and cities. Blue marble is the background layer, and cities is the layer which had all the red points. So that's how you tell a web map server what layers do you require. It will be better understood in the next picture. Let's say you have some street data or buildings data, vegetation data, um, and similarly you have n number of data sets like this. You don't possibly uh, you know make a way to integrate all of them in a single layer. That would be too much information for the user, but you can combine when you need them though. For example, in here we have integrated 3 different layers into a single map and giving it to the user, right? Okay, so we discussed about how you can make a request to a web map server, and let's now talk about views. So we generally talk about top views, right? As in when we go through a Google Maps or Bing Maps, we look at the image from the top, right? And it's not always the case. For example, I personally have been working with open source project called Mission Support System, and I've seen in a lot of places some atmospheric scientists or oceanographic scientists, what they do is they map the crust as well. For example, there is take the example of a landmass, right? So this is the view which we generally deal with. This is the top view, And for example, we make a vertical cut on the surface of the earth, and we see a view of a dungeon which is from the side. You might have seen this in 2D arcade games, right? So this is a side view. And for example, if you want to view in what line segment, what are the different, say, the density of water or the pressure of water, you want to visualize that, you can use a side view. And while they are not in the specifications of web map servers, you can always create your own. And I'm just telling you to make you understand that you can, the possibility or the as in the features it gives you is really beautiful, and you can make use of it to do really cool stuff using, I mean, to analyze some data or visualize them. You can do a lot of cool stuff. So legend image is something which generally users use to, in order to for example, there is a ambulance, sorry, there is a hospital which has a very big name, and you don't want to name the hospital in the map. So what you do is you just give an icon of a hospital, and the user can then understand that, okay, this is a hospital with the help of the map legend. Okay, so let's before we start with, you know, writing some code and getting some maps in our sheet of paper, right? So let's take a short detour to understand what are custom maps and how can we build one. What are the what map data do we need, and what are some Python tools which we need in order to build maps, and other stuff like that. So these are the two types of storage which we use to store data. They are raster and vector data. Think about it. So when you have a polygon, right, that says, like, let's take the country of Malaysia as an example. So we have a boundary which defines this on a geospatial system, right? So we have different coordinates, and if you join all the coordinates, we get a we get the map of Malaysia. And we, in order to store this, we need some sort of storage format, right? Let's not talk about those storage formats. So first is raster and then is vector. So let's talk about raster data first. So raster data has been primarily used in researching and researching of atmosphere or oceans and space, etc. So you would understand why raster data is used to store or used in that area of research, because raster is greater data format. For example, you have seen arrays, right, or lists in Python. They have a list of numbers, and in a 2D array you have a list of numbers in 2D format. For example, there is array 1, array 2, and all of this constitute an 2 by 2 array, right? So every grid has a integer associated with it, which in this case represents the green index of the layer, right? So you can see in this layer the map from this point to here is 1, which means it's less green. And in array 1, which is 8, it's a bit more green. So think about it like this. So when you have a satellite image, right, and you have red, green, blue layers, so think about it like this. There will be 3 of such raster layers, and so the first raster layer will show the green index, the second would show red index, and the third blue index. And this 0055, this can be the coordinates, right? So if you live by the lake, let's see, in here, in the white dot which I'm pointing to, so this must have a red, green, blue index associated with it. And if we try to plot this in a map, and we try to match this coordinate with, like, basically this place with the actual coordinate of this place, so now you have a idea how we can put real satellite images or any random images on a map, and we can see beautiful pictures of where you live, right? So yeah, so this is raster data, and there are 2 major ways to show raster data. First one is NetCDF, or it used to be HCDF, and then there is GeoTIFF, right? So okay, I'll tell you why this is necessary and how complex this is, not to use but to store them, right? Before that, let's talk about vector data a bit. So vector data is just 2D geometry. It's a plain 2D geometry. So let's say you have a map, and you try to, let's say, just focus on when I'm moving my mouse, right? I draw a point here, and then here, 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 here. I move all of my cursor all this way around, and that's how I define a boundary, right? And this is the state of Norway, right? And these are distinct geometric location, as in they can be vertices of a polygon, and we can store it in the form of a shapefile or GeoJSON, right? During the second part of the tutorial, we'll be looking at how we can use this geospatial data formats in order to plot our real maps. Okay, so we talked about raster data before, and we said that there are two ways to store raster data. They are NetCDF and GeoTIFF. Let's now talk about NetCDF a little bit. So NetCDF, it is used to store complex data formats, right? And think about it. So when take an example of a case where we have a time series of rainfall data set in our 3D space, right? There are locations in the form of latitude, longitude, and there is something called altitude, and there is something called time variation, right? As in what happened in time 0, time 1, until all the years, right? So think about how you plot it in CSV. In CSV, if you have a 2D array, let's say which specifies latitude, longitude, and the data associated with it, right? And you try to add a fourth dimension to it, let's say time, right? And that's complex, right? You have to create a series of CSV files, and it's really hard to do that. So NetCDF is a more efficient option to do it. And you can what you can do is imagine every dimension as an addition to the cube. For example, think about this cell, right? This cell contains a rainfall data point, right? There is a latitude, there is a longitude, and inside it is a rainfall data. There can be multiple of these data set. For example, this dimension, let's say this is the time dimension, right? So there can be some data here, and there can be a lot of cubes, right? This is how we add a fourth dimension to it. And if you want to add a fifth dimension, just think about it as taking the sheet, we cut the rectangle here and place a lot of rectangles on top of each other. We can do all of this cool stuff on top of NetCDF, right? So that is how we store some of our data. And now let's talk about how can we use the data we store to create beautiful maps on with Cartopy. Cartopy is a library in Python which you can use to build your custom maps, right? We talked about how data can be stored. We talked about what a web map server is, but there is a gap which we are making. Okay, how do we take a custom data and plot it in a map so that people can see it, right? So that's why Cartopy comes in, and it connects the bridge, right? So we have projections, background, like we talked about, right? So think about projections as EPSG, all the stuff we talked about while taking a light source and putting in a sheet and creating a map. Okay, so that's how coordinate reference system are made. And then you have background, right? When you go to Google Maps, you see green and blue layers to represent grasslands and oceans, right? So Cartopy, it helps you create these background images, and it has easy APIs to draw oceans or coastlines, continents, cities, etc., right? And you can plot your own custom data with something called add feature. And there are, okay, so these are some links to Cartopy. I'll be talking about Cartopy in length after this talk. And this is for a reference. If you want to take the slide up and see what is going on with Cartopy, you can check it out. Okay, so also before Cartopy, there used to be a library called Basemap, which has been deprecated since 2020 start. But I would recommend you can check Basemap as well. It's really cool. But for now and for future purpose, we would use Cartopy. Okay, so this is okay. While the scope of this talk doesn't allow us to work with NetCDF dataset in general, I have attached a sample code in which we can see how we can interact with a NetCDF file, right? For reference, NetCDF file are these complex data sets which store a lot of dimensions at once, right? So, and okay, so this is an example of basically a air temperature data set at 2 meters, which you can download from, if you check out Mera2 dataset on the internet, you can download the NetCDF file. Yeah, so this is, you can download the NetCDF data file from here. And what you can do after this is, okay, so this is a Python file, and you can use it later as well. I'll be happy to help with this. But I want you to understand this because this is only the start, right? You'll be able to plot. You'll be able to plot normal, simple shape files or GeoJSON on top of map. What after that? You can check out really complex geospatial data sets and try to plot it in a map. It's okay if you don't understand this now, but please save it in your bookmarks as reference, right? So let's say we try to import NetCDF, a data set from NetCDF 4. This is the library which helps Python to interact with NetCDF 5, right? So we start our data sets, and yeah, so in NetCDF there are two things called variables and dimensions, right? Dimensions are the same things which we found, which we talked about earlier, right? Their latitude, their longitude, and there is a dimension called time. So basically, when you visualize your geospatial data in a 3D space, it gets easier to see what dimensions are. And variables are a custom data which you store. For example, let's say in your 2D map, you are storing, there is a latitude, there is a longitude, and you want to store some data in the latitude longitude 2D array, right? Let's say for in here we have T2M, that is temperature at 2 meter data set. So this is a variable called temperature 2 meter. We are going to plot it, right? So we get the values of latitudes and we get the values of longitudes, and we try to import some matplotlib and numpy um, in order to plot this data, right? In order to transform the data so we can plot it. So base map package, we get it from matplotlib. Remember I talked about there used to be a base map library, so that comes handy in here. And so yeah, and then we get x, yeah, basically we get latitude, longitude, and we create a map. And then what we do in here, we squeeze temperature at 2 meter into a 2 by 2, sorry, not 2 by 2, a 2D array. And then yeah, that's how we plot the data, and the final map which you will get after running the code is this map, right? So this, okay, let's come back to Cartopy and how we can plot a very simple map, right? So it's as simple as importing a coordinate reference system as this, import cartopy.crs as ccrs, and then we try to import pyplot. And then what we try to is we plot some axis, and the projection can be plate carry. You remember projections, right? We talked about them some slides back, about 10-20 slides back, and they can be different projections. You can see a full list of projections supported by Cartopy in their website. And we plot the axis, and then we do ax.coastline. You see all of the images what we have, it is a coastline image, right? It doesn't have any country boundaries, etc. So that this line plotted all of these for us, and once we do a plot.show, we get this image, right? Okay, so we have now some idea as in how can we plot a custom map from a custom data sets, right? So we have a custom data, we have Cartopy to plot it for us, and we know how to share it with the world with the help of map servers, right? So let's now talk about the map service for a bit. What happens, as in how can you build a map like Google Maps on top of the custom data, right? So let's go through the component first, and in the end we're going to code a custom web map server. So okay, first of all, standards. So but why? Because there are 1,000 and 10,000 people creating their web map services, right? And there are a lot of people like us in the world. We use their custom maps, right? So we need to set a standard as in what the request has to be, what parameters do we pass, and all of that. So we have Open Geospatial Consortium in order to create and build this standard, and it's totally open. You can join in the discussions, and you can help make better decisions as well about revolving around the standards of web map services. This is a link to the standards PDF, and let's go check it out. Okay, so this is an overview, as in we have a different web map services, and yeah, okay, you can go through one of these, any one of these, and you can see what kind of standards do OGC suggest in order to build your custom web map server, right? Okay, here are some requests which we would see in a general web map service. So first is get capabilities. Think about it. You are a new user. You go to a web map server and check what services does it provide, right? So this is the first document which you get, right? This we are not going to create it because it will take some time, but just for the knowledge, just know that this is the first request which we should ideally make to a map server. There is a map service which promises that, okay, I'll give you some maps, and in order to get the maps, we need some data, right? What kind of maps does it give, what kind of coordinate reference system does it support, and all of that. For example, in here there is a contact person. This is some metadata associated with the web map service, right? And we have something called okay, this is a sample type of request which we will see later, called get map. This is the request we make to get a map, right? A png image or a jpeg or whatever image types it support, it will show us in the get capabilities document. It's intuitive, right? It just shows the capability of the map service, right? And we have something like, let me check out some layers it provides. Yeah, look at this. So okay, here are some coordinate reference system it supports, right? We can view different shapes of map in different coordinate reference system. And then there is something called layers, and in it is a bounding box for it, as in there has to be some limit on what, for example, if the map gives only map images of America, then it will give the bounding box of America. If it gives a bounding box for India, then it supports only bounding box for India, right? So there are different layers it provides. All of them is listed here, right? So we have in our map client, a map client like Leaflet or OpenStreetMap or Google Maps, they parse this capability document and show that, okay, hey, these are some layers the web map server supports, right? So yeah, that's get capabilities document for us. And let me go back to Chrome. Okay. So okay, get map. Get map, what it does is, like I said, there'll be certain layers and coordinate reference system defined. So what the map client does is, it parses the capabilities document and it gets us a map. For example, remember we saw a URL earlier which had some cities layer and we tried to tweak it. This is a similar request. We have a request called get map, and there is a spatial reference system or CRS, coordinate reference system defined, and we can specify the width and height of the map which we get. For example, let's just tweak it to 200 and let's see what happens, right? Like, yeah, the size shrunk. So you now have full control of what kind of map you want to get. Let me change it back to 480, and let's try to tweak some layers which we get with this map. And let's say we try to get a map of Africa and not the whole thing, right? Let's just go back to coordinates and try to filter what we get here. Let's not give, let's try minus 45 to 45, right? So this might be a coordinate of a part of Africa, and let this be 45 and 45 as well. So yeah, let's see. Okay, so that's how you tell a map service what image you want to get, right? And you can tweak the image type. Let's say I want to get a JPEG image. Yeah, I'm getting a JPEG image and stuff like that, right? So that's how get map requests work. So let's just go to a OpenStreetMap. Assume it's a web map server, right? So what I am doing when I'm scrolling back up, right, you see the full image occupying the screen, right? And when I go back down, okay, let's say this is a map which we get. The whole image is generated by a web map server, with which is the OpenStreetMap web map server, and it has some city layers and it has some green, gray, and blue, saying that whether it is a forest, land, or an ocean. And just for a split second, watch closely. But when I move up, you see some gray patches, right? So this is the web map server. Like, this is the map client, which is OpenStreetMap, querying for the map data from a map server and rendering them. So if we check out if we inspect how it is working, and you can see a better idea, right? And I'll go to network, I try to zoom in, and look at this request, for example, right? So this is an example of a web map tile server, which is a more recent spec. And think about it as, okay, yeah, think about this as a some sort of coordinate reference system, right? This is the latitude, longitude, and height. Think about it as that. So for every time you scroll up or zoom in, there's going to be a lot of requests to the web map server, which gives you all of these tiles, right? So that's how essentially web map services or web map tile services will talk about a bit later. And if you want to okay, so we'll talk about web maps and a client for web map server later, which you will use it in your own system. So yeah, so that's how web map servers gives us images to view in our map client. So yeah, there are different images, and you can, I'm not sure if you can see the response, but if you go here, yeah, you can see all of the types of images which you get in a map client, right? And you don't have to code the map client. We are going to use a leaflet uh, map client like this. It's going to be a small JavaScript and HTML file which you can use it. I'll give the file to you. You can run it in your system. And yeah, so this is a sample web map server. If you want to inspect this one though, let's check it out. Okay, right? So I zoomed in, right? And I see some requests. And think about it, it's the same request which we saw earlier, right? And it's a web map service request. And you can go back and see, oh yeah, check it out. The service is web map service here. And we are requesting a get map. And we are checking, we are giving some layers and some bounding box. And we must get a clean map. Oh, neat. Right? So we're going to build a same thing in our own system, in your own system, in my system. And yeah, we're going to have a lot of fun after this. Okay, so these are some instructions of the web map service tutorial, as in the stuff which you can do on your own, right? So you can follow this under three categories. The first one is observe only, right? This was the mode until now. You didn't have to do anything, right? The second is to understand web map services better, and it's totally fine. You can use or rebuild all of this on your own later. But if you still want to follow along, so you can understand the web map services better by doing uh, you must have Python 3, and you try to use virtual environment and create an environment for good practices. And let me share the document. And yeah, let's just finish it. You have to install Flask. Flask is a microservice, as in like micro Python, as in sorry, so a micro framework for web service, right? So, and OWS lib is a library which can help us to interact with the web map server, right? So the first thing which we are going to build is a local web map server, right? So your map can interact with your web map service in localhost. But what we are going to do is we are going to proxy the request, so that if a request comes to our server to generate a map, we try to go to yeah, basically we fetch it from another web map server, and we try to return the image. So it would look like we are using our own web map server, but essentially we are just copy pasting results or proxying the result from someone else, right? So this is the first thing which we will build, right? And the third thing which we will build is to create our own map vectors using Cartopy, and we are going to return it with our custom data sets, right? So okay, let's get started with it then. Let me share the document, and I'll just go through or talk about sample project structures or Python files, so everybody can get some time to install them, right? Even if you're not unable to install anything, just you just want to follow along and see along, I'll share all of the document, and the, as I said in the chat, I'll be sharing the slides as well and the code, so you can always use it. Meanwhile, I'll take about 5 minutes to just go through some as in normal geospatial stuff which you can do with Python, the Cartopy library, the what you can do with Flask. Of course, I mean most of us know what to do with Flask, but yeah, let's just, for some people who are still new to Python, let's welcome them and see. So okay, you have to do a Python 3 installation, and you can use Conda or virtual environment um, to yeah, to simulate a virtual environment to keep your system safe. And let's now go through Flask a little. So this is a very simple web map server. You just have to install, sorry, uh, mm, micro framework for web maps, web services, and you have to do pip install Flask, and this is some installation stuff. Let's just go through a get started example. And okay, there's quick start here. So yeah, this is a very simple app, and we are not going to be using any more than this. We just have to deal with some routes. And yeah, basically this is a function which is hit when we hit the route slash, and this is how we deploy the app, right? And we are not going to be doing this. We are just running. I'll give you a Python file to look at and run, right? So we are using a Flask server, so you get what we are trying to do, right? So we are trying to start a server, so every time someone requests our web map service, we return some results. So to return and interact with the client, we use Flask. OWS lib is to interact with a web map server, right? Remember when we talked about, like, basically the first step of our demo, first step of what we are going to code is a proxy web map server. So what we are doing is, once a request comes to our Flask app, what we do is we take the parameters, we request a custom web map service, and we get an image, and we return it, right? So OWS lib helps us to interact with web map servers, basically like a web map service client, right? So something like OpenStreetMap, but with Python, right? We can build a custom OpenStreetMap with the help of, or basically generating these images from a web map service client with the help of OWS lib. So in order to run the first example as well, you have to install OWS lib, Flask, and Python 3, right? So let's go back to yeah, we are going to be demoing all of this as well, but let's that is when everybody and me start with. Sorry, is there any question? No. Okay. So right. So the second demo which will be going for is to make these vectors. For example, sorry, OpenStreetMap. Yeah, so basically to generate these tiles on our own, we are going to generate all of these tiles on our own. We are not interacting with any other service, right? We are going to build, generate the image with Cartopy. So Cartopy uses matplotlib to plot the image, and we are going to export the matplotlib image and get the map image, and we are going to return it, right? We are going to be building this in the second demo, right? So this is the agenda for the coding part, right? First of all, we'll talk about Slippy Maps for a bit, something like OpenStreetMap. And I think we covered some bits when we were talking about OpenStreetMap in general and how does it work. So basically, check it out. When I'm panning out, there is going to be some blank screen in here, and it is being requested and filled by OpenStreetMap client, right? If I inspect the network, so these are some request calls which happen, right? Check it out. There are a lot of images being requested. If I zoom in, there's going to be new images requested. And if I get the tile, I think it is going to have some islands, etc. Yeah, check it out. So yeah, not this, of course. But anyway, oh yeah, this is the image which we got from this tile. So cool. So that's how Slippy map works. And that is just a fancy term to say that Google Maps is also a Slippy map. For example, any modern map which can zoom out, pan, etc., that's called a Slippy map. So yeah, and okay, we went through this tile. This is a sample web map tile server, right? So if you okay, to give you context on tile servers, these are some new spec, as in 7 and 63 represents a 2D grid, and 42 is the depth of the layer, right? And that's how we get a map image. But you saw how web map services, not this one, but the one we had layers and bbox, etc. And so web map tile server, you can think of it like a subset of web map server, right? So this is one. And then for our web map client, right, we are going to use a leaflet client for this. For example, I'll give you the HTML file. It doesn't have anything to do with Python. It's very simple. You can understand it when you see the HTML file, right? So this is a sample web map client from leaflet we are going to be using, right? We are basically going to be plugging this into our web map server which we build and serve with our own system, right? So yeah, this is an example. And Okay, let's now talk about. I hope people have installed OWS Live and whatever part they want to build, parts of this or parts of this, and or full of it. Your choice actually. It doesn't matter a lot, but yeah, let's. I'll be no. I don't have to close the slides. So okay, let's talk about OWS Live for a bit and what we can do with it. Right. I'll skip to the webmap server section, and what I will do is right. I'll just like copy this example. If you want to build on top of this, I'll just share the link with you people. Right. So yeah, that's OWS live link. You can skip to the WMS section and let's just run a couple of commands and see what we can get with it. Right. So I spawn a Python shell and I from OWS live I imported this. Let me just copy the whole thing to a document here. Yeah. We won't be doing a lot of stuff, but yeah. So essentially, what we'll be trying to do is we will try to start a web map service, and we'll try to get map, as in get a sample map from there. Okay, this doesn't work. Let me check out some. Okay, let me test this out. Yeah, so that web map service doesn't work. I'll just put the link of a web map service which work, and you can replace the URL with this one. And I hope it'll. Okay. Okay, so to answer Ruthie's question, you can skip installing Cartopy for now. It has a lot of stuff, as in it, for Cartopy, you'll be needing a lot of other stuff too, but you don't have to worry about it. You can just follow along the code. I'll be explaining everything, and later I'll set up a forum as well, so you can ask questions, and me or anybody listening to the talk or trying to contribute, they can help. So please don't worry about it, as in it's only a small change there. You'll see it better when you when I'll explain, I hope. Right. So thanks. Okay. So yeah, let's get on with it, and we'll try to see what layers does it provide, right? And let me go to the OWS lib documentation. And okay, so if I do a list of WMS contents, I'll see a list of layers it gives, right? So it has, so I started a web map service with this. Like this is basically a web map service client. And what I will try to do is I'll try to get this layer, right? And yeah, so if I replace it with this, and so styles are basically how you color the images, right? And it's not very necessary, as in you want to color the images as red, blue, or whatever, right? So this is important. Or you've seen Google Maps can have a dark mode or a bright mode and stuff like that. You can control that with the help of styles. And see, we are trying to use a projection system here, which is EPSG 4326. This is the bounding box of our so whatever the map we are trying to get. This is lat1, latitude 1, longitude 1, and sorry, longitude 1, longitude 2, latitude 1, and latitude 2, right? This is size of our image, the image format. And if you want a transparent equal to true, so I'll just copy paste this and try to get image of a map, and we're going to save it in a dummy file, like, right? And yeah, let's see how it turns out. So after this, the next step would be to integrate it with a proper Flask service, so we can point our own, you know, basically map client to use our map server. I'll be sharing both the files after this, right? So please don't worry about it. Don't have to do anything as of now. Just follow along, look at this. So yeah, it succeeded. So we got an image. Let's just try to open a file and write the image to it, and let's see what we get, right? Okay, so we saved our file to jpl mosaic visible.jpg, Yeah, this is the image we got from our custom web map service. If you, okay, I'm not sure if I can go to the URL, generate URL from here, but anyway, so this is what we get. So you get the picture, right? So when we hook our custom service to remote web map service with OWS lib, uh, we will be able to simulate a similar map, right? So okay, now, so this demo is done. The next thing in our agenda is to, yeah, this part is done. Okay, let's make a proxy with this is the part we are at, right? I'll take you through the gist which I wanted to share with you, and what files does it have and what can you do with it. Okay, everybody please go to the link, and it has a bunch of files, so you can download all of the files, right? And this is the HTML file which has, yeah, so basically what we are doing is we are trying to import leaflet, and in here we are trying to instantiate a web map service layer, right? So here we pass the URL, right? So this is where our Flask service has to be hosted, right? So localhost 5000 is where we would host our map service, right? And for layers we would know that yep, so OSM auto all is the layers which we want to get. If you remember, in my terminal I did a layer equal to OSM auto all. This is the layer which I got from here, from wms.list contents, right? So that's something. So from my leaflet service, sorry, from my leaflet example in the HTML file, I get this layer, and this is the CRS I supported, right? EPSG 4326. If you remember correctly, this is the same uh, SRS I used here, EPSG 4326. So this is important because you have to make it consistent. You have to stick to a certain coordinate reference system, because think about it, a latitude and longitude can have different meaning, and it will point to different locations in different spatial reference systems, right? So you have to make it consistent, right? That's something. And yeah, so download this file and save it in your directory where you are hosting all of the files during this tutorial, right? And the first file I would ask you to download and run is this file, right? And if you can see, it doesn't, you can just install logging or just remove it. I think you can do a pip install logging to get away. This is to log whatever you get, right? So as in like wherever you want to log anything, right? So if you can see this file, I'll just go through it, and so I would ask you or request you to download it in your own, the postmap v1. So this is where we are trying to proxy the web map service, right? So we have imported WMS from OWS lib, some stuff from Flask, some URL lib. This is, I think this comes bundled in with Python, and you don't have to worry about it. And yeah, you don't have to import logging. I just used it to log some bookkeeping stuff. So there is a class called before that there is a Flask app, and there is a web map service. This is OWS lib, which we try to do in the terminal, right? So there is a web map server class, and it has a get capabilities, which I'm just returning some dummy values, please don't mind, because what are basically what leaflet does is it doesn't get capabilities unless it asks for it. You can write your own capabilities document, but you don't have to do it now. It's not that important. You can basically, making a capabilities document is like we saw here, right? Okay, not this, but let me um, show you where, yeah, I think this is the one. Yeah, so this is a capabilities document. You just have to tell what CRS you support, and what layers do you support, and what are the bounding box do you support, and all of that. This is a very grunt work, and you have to do it at some point, but not now, not while you are trying to understand what web map service is all about. So okay, I'm just returning a dummy capabilities document. It is never needed, right? So this is a very important function. We'll look at it later, but let's come to how our routes are defined, right? So this is our main route. Every call to our web map server, as in every time our map will call our web map server, this route is hit, right? So if the query string is nothing, then we just return a dummy response or invalid request response, right? So after that we get the queries, and we try to get the request type. Okay, while we are discussing this, let's go back to the slides and check out this one, right? So I'll do is like query, I'll parser for URL. I'll use a dummy URL parser to show you how the queries are structured, right? So okay, cool. Oh no, this is bad. Okay, no problem. So we'll make it out here on from here. So we have something called sorry. So we have something called service, which is a web map service. And if you can see here, we are, yeah. So there is something called request service, which we are parsing to get the service type. And we are testing if it is get capabilities or get map. Then we are trying to, if it is a capabilities, then we are doing server.get capabilities. It will get it from here, get capabilities document. And if it is a get map request, then we are doing a produce plot, right? So this produce plot will have the image which we want to build, right? Or plot in the map, right? And then it will return data with some return format. The return format will be image JPEG, right? So remember, this is still a black box here. We don't know what's going on in here. We'll explain it in a bit. It's pretty simple, actually. I'm sure many of you, or almost all of you, would already know what's going on in there. But anyway, let's still continue the discussion. So if there is a get map in here, then we return the map we generated, right? And then if it is none of them, then we log that, okay, there was an invalid request, we raise a runtime error, and some bookkeeping stuff, right? So this is where we are trying to make the response and set the content type and content length, right? And we are returning the response. Now let's go to where the plot is generated, right? In the plot, what we have is, so we are trying to parse the B box. Remember, we got a B box here. Where is it? Okay, there is B box here. So B box is -180. This is longitude 1 and 180 is longitude 2. -90 and 90 are latitude 1 and 2. So we parse the B box, and where is it? Where did it go? Okay, so we parse the B box and we try to organize it in a way that, okay, so we are making a request to the web map service, which is hosted here, right? So yeah, so that's why we parse the B box and we specify the SRS, which is this, and we get the size of the image which we want, right? That will be the query.get height and width, which will be, we'll see what it will be while demoing the map. And we have an image format defined, and transparent will be true. So okay, so we get the image. What we do is we try to save it in a JPL mosaic visible.jpg. This will not be very necessary, or not at all necessary really. But yeah, after that we do an image.read. This will be the byte, basically a byte stream for the image, and we return it. So what we have here now, so in the full file we have an API which will return images when the web map client defined here will request it. Everything, all of this happens under the hood, as in what part of map, as in what image will I get for a map. The leaflet library handles all of this in front end, which is a simple HTML file. I'm sure if you dig deeper into it, you can implement the same in Python as well. So, but yeah, this is easy, very easy to set up. That's why I use that to demo. Okay, what we do now is let's run this, and yeah, let's run this, and if everything works correctly, we'll be able to see how everything is happening, right? So I go to my terminal, I close this, and let me check out to a branch. This is in okay, right? So this is the commit where I'm at. Okay, check out this, right? And I'll do, okay, okay, so if you have a Python file called postmap version 1.py, I'd request you to run postmap version 1.py. I save my version as git version. So but anyway, this is the file which is there. I'll show you. And yeah, it's taking the B box, it's making the request to a map service, and it's returning the image. And how do we test it? So test it in a way that give me a second, let me, okay, I'll try to open this in Finder and open it in Google Chrome, right? So yeah, if there is HTML file, you can try to open it with Chrome or Firefox. I'm sorry, your Safari, whatever, right? Boom. So we get something, right? Let's try to debug what happened. Uh, let's go to networks tab, which will tell us where did the request go to, right? So check this out. So my request went to localhost 5000, right? Localhost 5000, I have a server hosted um, which gives me some images, right? And this images is okay. If you remember correctly, I'm not sure I told you, but I'm trying to sorry, print. Yeah, I'm trying to print the b box and height and width here, but yeah, this is all printed. It's not necessary, but sorry about the mess. I was trying to debug it some hours back, but I forgot to. Anyway, so all of these requests are coming to our localhost service, and what is going on is I'm trying to make a request to a existing web map service here, and I'm proxying the result, right? And in the small amount of code, some of it is unnecessary, but in about 50 lines of code, I am able to see something like this happening from my own computer. Of course, there are HTTPS requests made to a custom web map service, which is defined here. But the next tutorial, which will be a bit hard to set up, but it's very easy. People who are finding it hard to set up Cartopy, they can always set it up later and see the code. It'll be very intuitive, and we can understand it completely fine, even if without executing it. But I'm sure this is easy to set up, and I'm sure everybody is running this code, and you can see it for yourself what is going on here. If I try to zoom out or zoom in to some part, yeah, you can see that. Okay, one more thing which you would notice is it is very slow, right? When I go to Google Maps, it's pretty fast. So there are some we'll talk about how to optimize our map service later, but for now there are some service which goes on, and we can get an image from it. I'll try to go in a browser URL, and yeah, we are getting an image. All of this is happening in our local host, right? Only the server which we hosted. um, so yeah, that's part one of the tutorial. And the second part, we'll try to build this custom images as in the tiles which we see. We won't, will, even if we shut off the internet, it will work. It has to work, right? So yeah, so essentially what Cartopy does, let me take you through Cartopy a little bit. So you know what to, where to go after this talk is over, right? Let's go through Cartopy docs a little bit before we jump into what example we are doing, right? Okay, so this is Cartopy. In Cartopy, we have a lot of stuff, and there is an installation guide. It's pretty descriptive, and there are some other people who have blogged about it as well. So I'm sure it's pretty hard because look at it. There are a lot of setup involved to set up geos, proj. These are some complex like C bindings to set up. That's why it's hard. That's why I split the tutorial into two parts where you can proxy the web map server or build on your own, the second part which we'll be discussing. But yeah, let's just get through the code once. I go to home and yeah, so in here we have a list of coordinate reference system which we can use. I think it will be better to make like visualize this with the help of examples. Please don't mind if you don't understand at the first glance at it. Uh, it, it might be very new, but I'm pretty sure you'd really like it once you get the hang of it. So yeah, what this example would be to just draw some custom maps. We are trying. Okay, Cartopy has some really nice features to do land, ocean, etc. On its, like, basically out of the box. We are not doing anything else for this. And this is a very small example which we would try to plot the state boundaries of Australia. And what we are doing is basically trying to plot a figure, and then this is a subplot with uh, basically this coordinate reference system. And the set extent, we would be using set extent next in order to crop the image, right? Unless we do a set extent, it will show us the image of a whole wide world. We don't want that. We want some latitude and longitude. Like, if you can correlate better, this will be the bounding box which we will get in our parameters, right? So this will be the bounding box. This will be the CRS which we use, and this is the stock image which we will also use. This is as in like stock image, as in a sample tile image which we generate with Cartopy. and it adds all of this blue, green, brown, tiles on top of our custom maps, right? So after that, what we do is we add feature like it's a state provinces lines, and we add this feature on top of here. And these are some, yeah, these are some metadata associated with the map. You can put anchor text on top of it like this one, right? So this is, you don't have to do it right now. I just wanted to tell you there's a lot of scope here. You can build a lot of cool stuff on top of Cartopy. And yeah, thanks to the people maintaining it, I mean, yeah, I have found it very useful. So there are also other if you remember me telling you, there is base map which was deprecated, but I think all of the maintenance of base map are also maintaining Cartopy more or less. And this is the library which will be updated here on, but you can use either of them. Base map is easier to get started with, but Cartopy is really, really handy. Okay, so okay, let's move on to our next example in the gist which I linked you with. So I hope everybody was able to run it. If not, we'll solve some issues during the Q&A section. And I think we have about 10 minutes left. Let's just complete the second demo in time, so we can have a small Q&A. Else, I'll also link to a forum or a Twitter thread we can chat on, right? Okay, so please download postmap v2.py, and it requires a lot of other stuff. And this is because my Python installation, the SSL, it doesn't point to the right SSL certificate. You can choose to skip it, or if the URL open fails for you, please add it. And if you're very wary about the security, then your decision. But yeah, this is there for that, right? So okay, I must tell you, most of the stuff here is same. Okay, this is unnecessary now because we are not using it anywhere. If I search WMS, not here in v2, right? So in here we are not using this anywhere, right? So yeah, this is dummy. You can choose to remove it, but most of the stuff here, at least the template, is really, really same with this, right? The only part which changes, if you are downloading it and seeing it in your local file, the only part which changes is produce plot, right? This is the only part which changes. Let's now talk about some more utility library which we try to import, right? And there are a lot of unnecessary stuff as well. I forgot to remove, really my bad, I'm sorry. Like PIL, we are not using PIL. You can choose to remove it if you want to. And okay, some of the stuff which we try to import here, which were not there in the postmap v1 version, right? The first is some matplotlib aggregator. I think the import is not filtered. It's really messy. It's actually my fault. I think we can improve on this. You can choose to remove the parts which are not used later on. But this is imported figure line 15, and I'm doing Shapely. I'm trying to use Shapely here. I think some Cartopy features are also imported, and that's pretty much it. I think we are trying to import the three things which we need here as line 15, 16, 17, and 18. Not 18, 20, right? And 21. Yeah, you'll know why 21 is used. Okay, so let's jump into produce plot. So this will be the final set of stuff we talk about during this tutorial, right? I hope people are taking something from this, right? This is really important because this is the end result. If you understand this, just know that you can build your own maps with any custom map data locally, right? Okay, so first is bbox. This is the same as what we had before, and we are trying to build a bounds, right? The bounds will be the same as, if you remember me explaining you, no, not this. Yeah, there is something called set extent here, if you remember correctly. This had longitude 1, longitude 2, latitude 1, and latitude 2, right? So we are doing the same thing. We're just reordering it. So in our web map service request, we get it in a different order. I'm just restructuring the order here, right? Now, in line 43, I am trying to create a figure and then trying to add a subplot with the plate carry projection. And I am setting an extent to the bounds. In this line, what happens is, in line 45, what happens is, if my web map server here requests for a bounding box, then I must make sure that only this part is drawn by Cartopy, right? So that's why I'm setting the bounds for, and then I'm putting a stock image. And there is a drawback here. The stock image is a fixed JPEG image, and its resolution isn't very good. I'll also link you to the repository where I'm hosting this code in a bit, where you can use a custom tile service, which sorry. So Cartopy will download the tiles for you, and you can use tiles instead of a stock image. But this is very easy to set up, so we are using a stock image. We are using to demonstrate Cartopy's capabilities. We are using C feature. We are basically with add feature in Cartopy. You can add your custom features to the map, right? You're plotting the map in an axis, right? And we are adding rivers here, right? So what is this? What is line 51 to 81? If you don't know about GeoJSON, and in our slides we talked about GeoJSON at some point. You can go back to it later, but right, okay, cool. So anyway, we talked about GeoJSON somewhere, and basically they are a type to store our custom geospatial data. For example, we have a list of coordinates here, and this shape file, right? Basically, shape is a, if you are unaware of Shapely, Shapely is a tool to interact with custom geospatial data. There can be geometries like this. There can be geometries in the form of PostGIS. Really not in the context of this tutorial, but if you just want to know, there are different types of other storage options for your custom geospatial data. So we have all of this. So we are instantiating a Shapely variable which would hold our custom geospatial data, which is this. And if you want to go really wild, then you can store these GeoJSONs in parts of your operating system, or basically setups, and import them from there, then load the Shapely file. It will work perfectly fine, right? So this is the Shapely feature, right? You have to do a C feature, and Shapely feature is a class which is present in Cartopy. I think you can find it in the documentation as well, but this is how you use it. We are adding the feature to Shapely feature, and bytes.io, this is a byte stream to store the figure data which we generate, right? So until now, what have we done is we are adding a stock image to see the background layers, and then we are adding rivers as a feature. We are adding our custom geospatial data as a feature, which is this, right? And then we are trying to save our figure into figure data, and this is to seek it. Basically, this is I got confused here. As in, if you have saved your figure into a byte stream, then you have to seek to the top of the byte stream. Yeah, and then you return the image you generated, right? So nowhere in here we have called this thing. You can choose to remove it if you like. So we are generating all the tiles on our own. And now when we run it, I'll go here. I'll stop the server and get branch, get checkout master, get log. I'll just go to the, yeah, I'll go to here, get this. Yeah, if you're downloading a Postman v2.py, I would suggest you run it, right? And now go back to your Chrome where you tried to run your, whoa, where did you go? Right, okay. So, okay, this is cool. Now you might already know that there are some flaws with it, as in there are some rectangle boxes. I'm not basically, this should not be there, because this is basically generated by the image, right? If I go here and try to go here, I'm not be able to see the black because the background is also black. But yeah, this is flawed, right? But it works. What works? And I'm able to generate my own custom tiles. And the most important part, which we haven't noticed yet, is if I go here and I scroll the map, yeah, this is the GeoJSON which we defined in our own file. In here, this is the coordinates. If you try to plot it, we have plotted our own geospatial data in a custom web map server which we built on our own. And yeah, this just works, right? It's really, really bad, but you can see borders here, which is not necessary. And if you can see the image we are generating as a very bad resolution if you go here, but yeah, it completely works. And we can do our own custom optimizations on top of it. And let me just finish some slides so we can conclude with the talk. Um, and then we can do a Q&A, and I can okay, so we built our own custom web map server from scratch. Yay! So I hope you took something home from this tutorial. And even if you didn't understand anything, you can we can talk it out later. I'll post a link to a forum or a Twitter thread. We can talk about it. But yeah, why did I decide to talk about it? Because maps are cool, and I hope at least one person among you found web map services cool. And best case scenario, everybody is excited about maps. We can do a lot of cool stuff on top of maps, because there are a lot of areas where scientists need our help to plot their visualizations. And there are wildfires, there are algae deposition we need to keep track of, and a lot of stuff. And we can use maps to track everything, right? Rescue missions, maps are used everywhere. You can help so many people with this, right? And so yeah, we can use Python to build all of that. And you can why should you contribute? Because to be a good human being, right? What does it hurt to help someone? So yeah, and they'll thank you a lot. Yeah, like I thank a lot of to people who helped me with my task. So yeah, and you can contribute. There are a lot of libraries which you can contribute to. They're all based out of Python, and they're linked on the slides as well. While I share the slides, you can go through them. And yeah, thank you. So you can contact me on Twitter or my email. And I'll go back to the question. So we can handle a few questions here here as well. Else, oh, sorry about that. I didn't want to do this, but I have to go to the question section. Yeah, I think we can start with the questions for 1 or 2 minutes if the organization. Oh, we have exceeded the time limit. But anyway, so let me just start. Yeah, the best option would be to, with this doc, I'll comment something down here. You can put your questions here in the doc. I'll try to answer them. Else, if I come up with a thread somewhere on the internet to start a Q&A section, we can do it there as well. And thanks a lot to the organizers to do this, actually, as in it's really hard. There are a lot of talks, tutorials, and thanks to PyCon APC organizers to do this. And yeah, thanks everybody for coming in, and let's have a Q&A session there or here. And really glad that all of you came and attended the session. I hope you all start loving maps a bit and build your own cool stuff on top of web map servers. Have a great day, everyone, and yeah, enjoy the time.